Welcome back. So we need to find the row index-th. I don't know how to pronounce index-th, this one. Which the row index is row of of Pascal's triangle. So we need to see here how we can do this. Like the Pascal's triangle starts with row 0 row, which is will be 1, and then we have one row, and after that we have in the row number 2 we have 1 2 1, and so on and so forth. So the problem is to generate the specific row without building the entire triangle up to that point. Especially since the constraints go up to like row, I guess, row 33. Okay, and the follow up mentions using like O of if you can look at this one. I don't know if it's visible. If I can just here, you should be use O of row indexed. Okay, so maybe we can do it with a single array that gets updated in iteratively. Like let's think, how does the iterative approach work for generating each row? So we need to think about that. Like for each row, we can starting from row 0. We can we can start here from row 0. Let me get the pen. We can start from row 0. And then we can generate the index row by row by adding adjacent elements. Wait. But if we do it in place, maybe from the end to the start, to avoid maybe overwriting values, I guess we can do that. So for example, if I'm trying to think with you guys. So if for example, if we want to generate row number 3, which is this row, the output will be 1 3 3 1. We need to see how the process will work. So first we start with row 0, which will be 1, and after that for row 1 we will have we can start with 1 and then add 1, because as you can see here, so we have like 1 and 1 in row 1. Yeah, then we end on, but maybe the way to build each row is to create a new array where each element except the first and the last, which are 1, is a sum of the element from the previous row and the one before it. But doing this for each row might require building each row step by step. However, using O of k space, where k is the row index, perhaps we can use a single array and update it in place. Let's think about this one. So suppose that we have to compute the nth row. For example, like let's say that we have this row, for example. Let's see, for now we have row index 2, which is this one, which could be no, let's row of index, this row, so which would be 1 2 1. How can we get that from the previous 1 and 1 array that we created? Maybe by starting with a new array of length 3, like we can do array of have 3 length, and set the first and the last elements to be 1. Okay, the first and the last elements will be 1, and maybe by and the middle elements as sums of the adjacent pairs from the previous array. But if we want to do it in O of k space, maybe we can generate the array in reverse. Wait. Here is a common approach we can think about it. Like we can start with an array initialized to 1, and then for each row up to the row index, iterate from the end towards the beginning, and add the current elements and previous one. I guess let's see, like for example, for row index 3, this one, oh no no no, this one, row index 3. Can I just remove this one? Yeah. So for row index 3, if we try to think about that, so if we start with one array, then for each subsequent row up to 3, we, like for row 0 where equals 1, we start row 1, which will be 1 1, or perhaps build it by adding elements. Maybe maybe the process is initialize the array as 1, then for each row from 1 to row index, and add 1 to at the end. I guess we can do that. Okay, okay. The key approach, like the key insights, is to build each row iteratively in place, starting from the first row, which is row 1. Each subsequent row can be constructed by adding elements in reverse order to avoid overwriting values that are still needed. We can, okay, let just, okay, I did talk too much. I guess it's be better if I started in the code. The solution is pretty simple. So first we will have our array, which will be let row equals 1. Okay, and I will say for let I equals 1 and I less than or equal row index. Okay, and the I should be plus plus. Okay, and row dot push will be, I put 1 here because we have to have the beginning should be always 1, and the end as well. And after that I'll say I make another loop for let j equals row dot length minus 2, because at the end as well it will be 1. And I will also j should be bigger than 0, and j minus minus. Okay, and row of j should be plus equal row of j minus 1, and I guess we can return row, and that's it. Let's see. Okay, so the approach here, as you can see, or I don't know if you can see or understand it. So we initialize, start with the first row with will be equals 1 as always, you can see here. And after that we iterate, we have iterative construction. So for each subsequent row up to the row index, we append 1 to the end of the current row, like as each row ends with 1. We update the elements from the second last to the second element to the second element by summing the current element and the previous element. This is done in reverse to avoid overwriting values permanently. This approach ensures, let's submit the code first and see if it works or not. Yeah, it works. So this approach ensures that we use only one single list that is modified in place. And yeah, I guess I did talk too much about the solution for this problem. I don't know if you like this or not. If you don't like this, I will not do it anymore. I will just go to write a hit in the description and solve everything directly. For this video, I just tried to try new thing, which is to think with you guys. I don't know if it was a right approach or not though.